What up? We are doing the physical science review worksheet in the folder for potential energy, kinetic energy, work, and power. So, as noted before, I'm expecting that you guys have the notes on that stuff. Don't worry about the simple machines. We're just going to move on from that since, well, COVID-19, Okay, so stored energy is potential energy. Object due to motion is kinetic energy. Uh, Energy, we're using joules, which is a capital J. How do we get energies, plural apparently, in our bodies? We eat food. When you raise a book up, put it on a shelf, then it has potential energy. Okay, where does that come from? Well, it's from the food that I eat, right? That's the main idea. And if you wanted to trace it all the way back down, it comes from the sun and the radiation being released there. So what's the equation for work? Work in joules is force in newtons times distance in meters. Seven's asking you about force, saying if you push on the wall for an hour as hard as you can, you get so tired that you just can't stand up anymore. But did we do any work? We're assuming the wall doesn't move. So the question, did it move? No. Okay, so if work is force times distance, it doesn't matter how much force. Say I put 1,000 or 1,000,000 newtons of force into the wall. If it didn't move, that means times 0, I get 0 joules of work. Then we got a couple math problems here. Kinetic energy is 1/2 times mass times velocity squared. I got a mass of 2,000 kilograms and a velocity of 25. So now I'm just going to plug it into this equation. M is 2,000 kilograms. V is 25 squared. So remember, when you plug it into your calculator, you got to do 25 squared first, or 25 times 25. Or use a squared sign, times 2,000 times 0.5. And, sorry, that math took me a long time. What I get is 625,000, and it's energy, so joules. Okay. Here I got book placed on the top shelf of bookcase has a mass of 3.5 grams. The shelf is 2.4 meters. That's the height. How much potential energy does it have? Potential energy is mass times gravity times height. So this is equal to mass, 3.5 kilograms. I'm going to put it in parentheses so it's easy to understand, times 9.8 meters per second squared. That's the acceleration due to gravity. Remember, mass times gravity is weight, which is a force, times height, which is 2.4 meters. Multiply all that out, it's still energy, so my label will still be joules. 3.5 times 9.8 times 2.4. 3.5 times 9.8 times 2.4. And I get 82.32 joules of energy. And now we're going potential and kinetic, kind of what we worked on the week before. Arcs in a break here. So maximum potential energy is the highest point. That would be letter A. Maximum kinetic energy would be at the bottom, which would be letter B. All that potential turns in kinetic, assuming there's no friction or air resistance. Potential and kinetic would be on the top of this littler hill, C. And maximum or minimum velocities where it's starting. It's moving the slowest up there. Maximum velocity is where it's all kinetic. It's letter B at the bottom. Okay, next one. Pat has a mass of 55 kilograms and walks 4.5 meters upstairs. How much work does he do? Well, as we talked about in this problem, mass times gravity actually gives you a force. So work is equal to force times distance. So a lot of times what he's doing is increasing his potential energy by doing work. Okay, so the force in this case is his mass times gravity, which is 55 times 9.8, which is going to give me 539 newtons. That's how much force is being applied to move up the stairs. And then the distance is 4.5 meters. So now I can just plug it in. I get 539 newtons times 4.50 meters is going to be work of 2,000 425.5, and this is also measured in joules. Work is measured in joules. Okay, this is a much simpler work equation. Force times distance, which is equal to 300 newtons. Newtons is force times a distance of 30 meters. It's going to give me 9,000 joules of work being done. Okay, 13. True or false? Both these are true. When an object falls, potential changes kinetic. Great. Marked it true. I'm going to make it small x so it's easier to see. 14. When you do work, you lose energy. I mean, that's true. You're expending energy. But remember, energy cannot be created or destroyed. It can only be transferred or transformed. So you're losing energy, but you're using it to do work. So it's transferred into the movement of that object. Okay. Lastly, I'm just going to make a point here. So maximum potential energy is the highest point on this roller coaster, which should be right here. Maximum PE, right there. And maximum kinetic is the lowest point, which would be right here. KE stands for kinetic energy. Okay. Side note, all that energy is, we're assuming in this case, transferred. Okay, so it would, in theory, be able to come back to the top of the hill if there's no friction or air resistance. Okay. Well, let me know if you guys have questions. Good luck.